Chapter 6, Advanced SQL, number 2. In this chapter, we're gonna study several queries to create dynamic and materialized view. Also, we're gonna understand common use of these database triggers and stored procedure. And then we're gonna study SQL 2011 and SQL 2016 standards and explain SQL enhancement and extension. Union combining query. Combine the output union of multiple query together into a single ledger table. With union query, the quantity and data types of the attribute in the select clause of both query must be identical. Select C1.customer ID, customer name, order quantity, largest quantity as quantity. From customer table, C1, order table, O1, order line table, Q1, where C1 table dot customer ID equal O1 table customer ID and O1 table order ID equal Q1 table order ID and order quantity equal open parenthesis select max order quantity from order line table union select C1 table dot customer ID customer name order quantity smallest quantity from customer table C1 order table O1 order line table Q1 where C1 table customer ID equal to O1 table customer ID and O1 table order ID equal to Q1 table order ID and order quantity equal open parenthesis select minimum order quantity from order line table close parenthesis order by 3. So the query determine the customer who have in a given line item purchased the largest quantity of any time value product and the customer who has in a given line item purchased the smallest quantity and return the result in one table. Notice that an expression quantity has been created in which the string smallest quantity and largest quantity have been inserted for real readability. The order by clause has been used to organize the order in which the rows of output are listed. Figure 6-9 break the query into part to help you understand how it processes. Is there any other way to answer this question? In addition to using union, could you instead have answered it using one select and the complex compound where clause with many and or? In general, the answer is sometimes. Another good academic answer, right? It depends. Often, it is simply easiest to conceive of the right query using several simply select and union. Or if it is a query you frequently learn, maybe one way will learn more efficiently than another. You will learn from experience which approach is most natural for you and best for a given situation. So result, customer name, contemporary cursor, quantity 1, smallest quantity, 2, value furniture, yeah, quantity, order quantity 1, quantity, smallest quantity, and customer ID 1, customer name, contemporary cursor, order quantity 10, largest quantity. This query determines the customer who has in a given line item purchased the largest quantity of any fine value product and the customer who has in given line item purchased the smallest quantity and return the result in one table. To use the union clause, each query involved must output the same number of columns and they must be union compatible. This means that the output from each query for each column should be of compatible data type. Although this query involves subquery, this is not necessary for union. It just so happens we are doing it in this example. In general, a union is structured like this: select statement, union, select statement. It is possible to use union with many different select statements. Here we perform a single union operation combining just two of them. Another feature of this example, it is possible for the select clause to include retro value in each return column is list. See the words smallest quantity and largest quantity. These are not value in the table, but can still be shown in the result. Conditional expression using case keyword. Select case when product line equal 1, then product description, else shop, and as product description from product underbar T. A case expression acts like an if-then statement. It allows you to choose what will appear in a column of the result set, depending on a condition. Result, product description and table, blah blah blah, writer task. Subquery. Sometimes, no matter how clever you are, you can get all the rows you want into the single answer table using one select statement. Fortunately, you have a lifeline. The union clause is used to combine the output from multiple queries together into a single result table. To use the union clause, each query involved must output the same number of columns and they must be union compatible. This means that the output from each query for each column should be of compatible data type. Acceptance as a compatible data type varies among the database management system product. When performing a union where output for a column will merge to different data type, it is safest to use the cast command to control the data type conversion yourself. For example, the date data type in order table might need to be converted into a text data type. SQL does not include an if-else statement. Unlike procedure programming language, the case keyword was introduced to accommodate this need. The case syntax has four possible forms. The case form can be constructed using either an expression that equates to a value of predicate. The predicate form is based on three-value logic: true, false, don't know, but allows for more complex operations. The value expression from queries a match to the value expression. So these are the first two forms. Null if and coalesce are the keywords associated with other two forms of case expression. The query select case when product line equal 1, then product description, else shop and as product description from product table. More complicated SQL query. Production databases contain hundreds or even thousands of tables, and table could include hundreds of columns. So sometimes query requirement can be very complex. Sometimes it's useful to combine queries through the use of view. If you use a view, which is a query, you could have another query that uses the view as if it were a table. We have kept the example used in chapter 5 and this chapter simple in order to make it easier for you to concentrate on the piece of SQL syntax being introduced. It is important to understand that production databases may contain hundreds and even thousands of tables, and many of those contain hundreds of columns. While it is difficult to come up with complicated queries from the four tables used in chapter 5 and this chapter, the text comes with the largest version of the Pine Valley Furniture Company database, which allows for somewhat more complex query. This version is available on this book website, and here are two samples drawn from that database. Question 1. For each salesperson, list his or her biggest selling product. Query. First, you can define a view called T-sales, which compute the total sales of each product sold by each salesperson. You can use this view to simplify answering this query by breaking it into several easier to write query. For each salesperson, list his or her biggest selling product. Create view T-sales as select salesperson name, product description, sum order quantity as total. From salesperson table, order line table, product table, order table, where salesperson table, salesperson ID equal order table, salesperson ID, and order table, order ID equal to order line table, order ID, and order line table, product ID equal to product table, product ID. Group by salesperson name, product description. Next, you can write a correlated subquery using the view. Select salesperson name, product description from T-sales as A, where totals. Select max totals from T-sales B, where B dot salesperson name equal A dot salesperson name. Notice that once you had created the T-sales view, the correlated subquery was rather simple to write. Also, it was simple to conceive of the final query once all the data needed to display were all in the set created by the virtual table of the view. Here we see an example of creating a view which will be a permanent object in their database. Like a table, then we use the view as if it is a table. We discuss view in more detail later. The view is called T-sales and consists of the aggregate query involving a join of three tables. T-sales returns the total sales of each product sold by each salesperson. The query below it uses T-sales as if it were a table. Note that this query involves a correlated subquery. This query shows the biggest selling product for each salesperson. Tips for developing query. Be familiar with the data model, entity, and relationship. Understand the desired result. Know the attribute desired in result. Identify the entity that contain desired attribute. Review entity relationship diagram. Construct a where equality for each link. Fine-tune with group by and having clauses if needed. Consider the effect on unusual data. It is important to test your query against a set of test data that include unusual data, missing data, impossible data, or value, etc. Query efficiency consideration. Instead of select asterisk all, identify the specific attribute in the select clause. This helps reduce network traffic of result set. Limit the number of subquery. Try to make everything done in a single query if possible. If data is to be used many times, make a separate query and store it as a view. Subquery can be very useful, but can also cause computational overload. This is especially true for correlated subquery. Suppose, for example, you had a correlated subquery where the outer query was processing through 10,000 rows. This means the subquery would execute it 10,000 times. So in effect, that one overall query involved 10,001 real query. This is another reason it is important to test your queries. Not only must they be able to execute, but they should produce valid result in a reasonable amount of time. Guidelines for better query design. Understand how indexes are used in query processing. Keep optimizer statistics up to date. Use comparable data type for field and retro Write simple query. Break complex query into multiple simple parts. Don't nest one query inside another query. Don't combine a query with itself. If possible, avoid self-join. Create temporary table for groups of query. Combine update operation. Retrieve only the data you need. Don't have the database management system sort without an index. Run. Consider the total query processing time for ad-hoc query. All options are not available with every database management system, and each database management system has a unique option due to its underlying design. You should refer to reference manual for your database management system to know which specific tuning options are available to you and your organization. Using and defining view. The SQL syntax shown in figure 5-6 demonstrated the creating of for-based table in a database schema using Oracle 12c SQL. This table, which are used to store data physically in the database, corresponded to relations in the logical database design. By using SQL query with the relational database management system, it is also possible to create virtual table or dynamic view, whose content materialized when referenced. This view may often be manipulated in the same way as a base table can be manipulated. Through SQL select query, materialized view, which are stored physically on a disk and refreshed at appropriate interval or event, may also be used. Dynamic view, a virtual table that is created dynamically on request by a user. A dynamic view is not a temporary table. Rather, its definition is stored in the system catalog, and the contents of the view are materialized as a result of an SQL query that uses the view. It is different from materialized view, which may be stored on a disk and refreshed at interval or when used, depending on the relational database management system. Materialized view copies or replicas of data based on SQL query created in the same manner as dynamic view. However, the materialized view exists as a table, and thus care must be taken to keep it synchronized with its associated base table. So materialized view, copy or replication of data. Data actually stored must be refreshed periodically to match corresponding base table. But dynamic view is a virtual table created dynamically upon request by a user. No data actually stored. Instead, data from base table made available to user based on SQL select statement on base table or other view. Views provide user controlled access to table. The term base table refers to the table containing the raw data. So a dynamic view is a virtual table, whereas a materialized view is an actual table generated by copying data from the base table query. sample create view command. Create view expensive stuff underbar view and select product ID, product description, product standard price from product table where product standard price greater than 300 with check option. View has a name and also view is based on a select statement. Check option works only for update over view and prevent update that would create rows not included in the view. Advantage of dynamic view. As you know, the advantage of dynamic view, you can see, simplify query commands, assist with data security, enhance programming productivity, contain most current base table data, use little storage space, and provide customized view for user, establish physical data independence. Although views assist with data security, don't rely solely on views for security. There are more important security measures. Also, use processing time each time view is referenced may or may not be directly updatable. As with all SQL construct, you should use view with discretion. Like dynamic view, materialized view can be constructed in different ways for various purposes. Table may be replicated in whole or in part and refreshed on a predetermined time interval or triggered when the table needs to be accessed. Materialized view can be based on query from one or more tables. It is possible to create summary table based on an aggregation of data, copies of remote data, then use distributed data may be stored locally as materialized view. Trigger and routine. Prior to issuance of SQL 1999, no support for user-defined function or procedure was included in the SQL standard. Commercial product, recognizing the need for such capability, have provided them for some time, and we expect to see their syntax change over time to be in line with the SQL 1999 and SQL 2016. Trigger and routines are very powerful database objects because they are stored in the database and controlled by the database management system. Thus, the code query required to create them is stored in only one location and is administered centrally. As with table and column constraint, this promotes stronger data integrity and consistency of use within the database. It can be useful in data auditing and security to create logs of information about data update. Not only can trigger be used to prevent unauthorized change to the database, they can also be used to evaluate changes and take action based on the nature of the change. Because triggers are stored only once, code maintenance is also simplified. Trigger a named set of SQL statements that are considered triggered when a data modification, example insert, update, delete, occurs, or if certain data definitions are encountered. If a condition stated within a trigger is met, then a prescribed action is taken. The routine program module that execute on demand, function routines that return values and take into parameters, procedure routine that do not return value and can take input or output parameter. Both trigger and routine consist of block of procedure code. Routines are stored block of code that must be called to operate. They do not run automatically. In contrast, trigger code is stored in database and run automatically whenever the triggering event, such as an update, occurs. Trigger are special type of stored procedure and may run in response to either database manipulation language or data definition language context commands. Triggers, syntax, and functionality vary from relational database management system to relational database management system. Figure 6-13 trigger contrast with stored procedure. Based on Mullin 995, procedure and function are called explicitly. Triggers are event-driven. So procedure and function are called explicitly by the user of the database. For example, an application program. When calling a procedure or function, you may pass it parameters. Function, unlike procedure, will actually return a value. In both cases, there could be several queries or updates done to the database. Triggers are not called explicitly. Instead, they are invoked as a result of some sort of database action, such as inserting a new record, modifying an existing record, or deleting a record. They could also be invoked as a result of data definition language statement to alter a table. Trigger 6-14 simplify the trigger syntax equal 2008. Create trigger, trigger underbar name before after instead of insert delete update on table name. For each row statement, when search condition, trigger SQL statement here. Example, data manipulation language trigger. Create trigger, standard price update. After update of product standard price on product table. For each row, insert into price update table values, product description, sysdate, product standard price. In this trigger, the event is the update of product standard price. The condition is for each row, not just a certain row. And the action after the event is to insert the specified values in the price update on the table, which stored along of when sysdate the change occurred and important information about change made to the product standard price of any row in the table. Example of data definition language trigger. Create trigger safety on database for drop table, auto table. As print, you must disable trigger safety to drop or auto table. Rollback. Trigger may occur either before, after, or instead of the statement that allows the trigger is executed. Data manipulation language trigger may occur on insert, update, or delete commands. Question. Remember what data manipulation language stands for? Answer. Data manipulation language. Question. Remember what data definition language stands for? Answer. Data definition language. This sample data manipulation language trigger will execute after an update of the product standard price column of the product table. It will add a new row to the product update table and use the new value of the product description and price for this new row. Data definition language triggers are generally most useful to database administrator. A developer who wish to include triggers should be careful because triggers fire automatically unless a trigger includes a message to the user. The user will be unaware that the trigger has fired. Also, trigger can cascade and cause other triggers to fire. Figure 6-15 syntax for creating a routine, SQL 2011. Create procedure, create function, routine name, parameter, return data type, result cast. For function only, language, parameter style, specific, deterministic, not deterministic, no SQL, contain SQL, read SQL data, modify SQL data, returns null on null input, called on null input, dynamic result set, unsigned integer, static dispatch, new save point label, old save point label, routine body. So example, data definition language trigger. Create or replace procedure product line sale as begin. Update product table, set sale price equal 0.0 multiplied by product standard price, where product standard price is greater than or equal to 400. Update product table, set sales price equal to 0.85 multiplied by product standard price, where product standard price less than 400. And this simple SQL procedure will execute two SQL statements, and there are no input or output parameters if present parameters are listed and given SQL data type in a parenthetical clause after the name of the procedure, similar to the column in create table command. The procedures scan all rows of product table, product with a product standard price of 400 or higher are discounted 10%, and product within a product standard price of less than 400 are discounted 15%. As with other database object, there are SQL commands to create, alter, replace, drop, and show the code for procedure. The following is an Oracle code module that will create and store the procedure name, product line sales in our slide. Calling the procedure, Oracle return the command procedure created. If the syntax has been accepted to run the procedure in Oracle, use this command, which can be run interactively as part of an application program or as part of another stored procedure. SQL greater than execute product line sale. Oracle gives this response. SQL procedure successfully completed. Product table contains the following: data dictionary, facility. Relational database management system store database definition information in secure system created table. We can consider this system table as a data dictionary. Becoming familiar with the system table for any relational database management system being used will provide valuable information, whether you are a user or database administrator. System table that store metadata. Users usually can view some of these tables. Users are restricted from updating them. Example in Oracle 12c, DBA underbar table, description of table, DBA underbar user, information about the user of the system. Example in Microsoft SQL Server 2016, sys.columns, table and column definition, sys.index, table index information. All of these table and view are used internally by the database management system, but you can also query them. For example, you could find the owner of the company's table. Here is an example. If Fine Valley Furniture's database was stored in an Oracle database management system, select owner, table name from DBA underbar table, where table underbar name equal to product underbar table. SQL enhancement extension. User-defined database type. Subclasses of standard types of an object type. Analytical function for OLAP. Ceiling, floor, sort, length, dense underbar length, roll-up, cube, sample. Window, improve the numerical analysis capability, new data type. Big integer, multiset collection, XML. Create table like, create a new table similar to our existing one, merge. Programming extension, persistence tool module. Capability to create and drop code module. new statement, case if, loop for, while, etc. Make SQL into a procedural language. Oracle has proprietary version called procedural language SQL, and Microsoft SQL Server has Transact SQL. To give an idea of type of information found in system table, consider lots of SQL enhancement extension. Chapter 5 and this chapter have demonstrated the power and simplicity of SQL. However, reader with a strong interest in business analysis may have wondered about the limited set of statistical functions available. Programmers familiar with other language may have wondered how variable will be defined, flow control established, or user-defined data type created. SQL 1999 extended SQL by providing more programming capability. SQL 2008 standardized additional statistical function. And SQL 2011 introduced multiple refinements to the change implemented in SQL 2008. In addition, the most important new element in SQL 2011 are the temporal feature, which allows significantly more sophisticated treatment of time-varying data. They will be covered briefly after the coverage of the analytical feature. SQL 2008 adds a set of analytical functions referred to as OLAP, Online Analytical Processing Function, as SQL language extension. That's all. We studied a lot today. Have a great day. Bye.